Okay, this is a review for the quiz on the last 3 lessons: special right triangles, trigonometric ratios, and trigonometric inverses. Okay, for numbers 1 through 8, find the missing side lengths. Leave your answers in simplest radical form. Now, that's a hint that you're not going to use trigonometry on numbers 1 through 8, because when you use trigonometry, you get decimals, right? Remember? You always get decimals when you do the trig, sine, cosine, and tangent. So numbers 1 through 8, these are the special right triangles. Okay? Number 1, you have a 45-degree angle and a 90-degree angle. So I mean, this also has to be 45 because all the angles add to 180. You have 2 rules. I'll just put them right here so you can see them. We have the leg. We have the hypotenuse and you want the leg. So we're going to use the bottom formula. Okay? Leg equals hypotenuse divided by square root of 2. So let's start with x. X equals the hypotenuse, which is 10 square root of 2, divided by the square root of 2. Again, I'm using this formula. Top one. The bottom one. I'm using the bottom one. Leg equals hypotenuse divided by square root of 2. So x equals 10 square root of 2 divided by square root of 2. And the square root of 2 is divided out, and you just get x equals 10. Now think back to the isosceles triangle theorem and the converse of the isosceles triangle theorem. If these 2 angles are the same, then the 2 sides opposite them are the same. So since x is 10, y is also 10. Okay, number 2. Again, since this is 45, so this angle also has to be 45. So we have 45, 45, 90 triangle. And we know both legs have to be the same. So if this is 3 square root of 2, then the other leg, which is n, is also 3 square root of 2. Perfect. Now we have to find the hypotenuse. So let's use the top formula. Hypotenuse equals leg times the square root of 2. So the hypotenuse here is m. It's going to equal the leg, which is 3 square root of 2, times the square root of 2. Again, I'm using the top formula right there. The square root of 2 times the square root of 2, you should know that right away, is 2. The square root of any number times the square root of the same number is just the number without the square root symbol. So 3 times 2 is 6. M equals 6. Number 3, this is another 45, 45, 90 triangle. This time you want to solve for the leg because we have the hypotenuse. So we're going to use the bottom formula. Leg equals hypotenuse divided by square root of 2. So let's start with A. A and B are going to be the same thing because they're both legs in the 45, 45, 90 triangle. So let's do A equals 10 divided by the square root of 2. You cannot leave a square root in the denominator, so you have to rationalize. You have to multiply by square root of 2 over square root of 2. That comes back to the very first lesson in this unit. It goes way back. Way back. Okay, so when you do that division, you get, the numerator is 10 square root of 2. We know that. We just talked about this, but the denominator is the square root of 2 times the square root of 2, which is just 2. And now you're going to do 10 divided by 2 is 5 square root of 2. A equals 5 square root of 2. And again, both legs are the same in the 45, 45, 90 triangle. So if that leg is 5 square root of 2, then the other leg, which is B, is also 5 square root of 2. Okay, number 4. Okay, we got another 45, 45, 90 triangle. So both legs are the same. So that means y also equals 9 square root of 2 divided by 2. It looks messy, but that's the answer. Right over here. Now let's get x. X is the hypotenuse, so it equals a leg times the square root of 2. So hypotenuse x equals 9 square root of 2 divided by 2 times the square root of 2. That formula right there. So it means you have x equals 9 square root of 2, square root of 2, divided by 2. If you want to think of this as being over 1. The square root of 2 times the square root of 2 in the numerator is 2. So x equals 9 times 2, divided by 2. These you can just divide out and say x equals 9. Or you can do 18 divided by 2 is 9. Okay. So numbers 1 through 4, those are 45, 45, 90 triangles. And now numbers 5 through 8, these are all going to be 30, 60, 90 triangles. So for these, we have these 4 shortcuts. All right. Okay, so for number 5, let's just label this angle as 60 because all the angles have to add to 180. And this is the hypotenuse. This is the short leg, SL, and this is the long leg, LL, because they're crossing a 60-degree angle. And that's the short leg because they're crossing a 30-degree angle. So let's get the short leg right away. You don't have to label this if you don't want. But I'll say the short leg equals the hypotenuse divided by 2. The short leg is y, so y equals 12 divided by 2. Y equals 6. You'll notice there's no formulas directly comparing the hypotenuse and the long leg because that's just too complicated. It's a little messy, so I like doing everything in terms of the short leg. Okay. Now we can get the long leg, which is x, because long leg equals short leg times square root of 3. So x is going to equal short leg, which is 6, times the square root of 3. And that one's done. Number 6, let's label this as 30 degrees. This is the hypotenuse. This is the long leg. I'll put LL for short. And this is the short leg. I'll put SL for short. Okay. Since we have the short leg, we can solve for either one next. I'll just go with the long leg. Let's do the long leg next. So let's solve for n. Long leg equals short leg times square root of 3. So n equals 2 square root of 3, because that's the short leg, times the square root of 3. Long leg equals short leg times square root of 3. Square root of 3 times square root of 3, you should know, is 3 right away. And 2 times 3 equals 6. Now let's get the hypotenuse. Hypotenuse equals 2 times the short leg. That's easy enough. Hypotenuse equals 2 times the short leg. So it's going to be 4 square root of 3. Number 7, let's label this angle as 30 degrees. And we have x as the hypotenuse. Again, I like to label this just so that way it might be a little easier for you. This is the long leg, LL, and this is the short leg, SL. You don't have to do that, though. Let's start by looking at our formulas again to figure out what we can do next. We have the long leg, so I'm going to solve for the short leg next. Let's solve for the short leg. Short leg equals long leg divided by square root of 3. Short leg equals long leg divided by square root of 3. So y is going to equal 6 divided by the square root of 3. You cannot have a square root in the denominator, so we're going to rationalize, multiply by square root of 3 over square root of 3. So my numerator becomes 6 square root of 3. And my denominator, the square root of 3 times the square root of 3, you should know is just 3. And 6 divided by 3 is 2. So y equals 2 square root of 3. Now we can get the hypotenuse because we know the hypotenuse equals 2 times the short leg. And we just found the short leg, so we're going to do 2 times that. Hypotenuse equals 2 times the short leg, which is 2 square root of 3. So x equals 4 square root of 3. Okay, last one. This is the 30-degree angle. We have the long leg, so we can find the short leg next. Short leg equals long leg divided by square root of 3. Again, let's label. This is the hypotenuse. Short leg and long leg. Let's find the short leg y. Square root of 15 divided by 2. Divided by the square root of 3, which is the same thing as multiplying by 1 over square root of 3. That's going to give me the following. Square root of 15 divided by 2 square root of 3. There's a couple ways to go about this now. I'm guessing most people are going to do the following, so I'll do the following. I'll multiply by square root of 3 over square root of 3. So my numerator is going to stay. Oh, actually, my numerator becomes square root of 45. My denominator is 2 times 3, which is 6. The square root of 3 times square root of 3 is 3. My numerator I can simplify to square root of 9, square root of 5. Square root of 9 becomes 3. And 3 over 6 becomes 1/2. Now there is an easier way to do this one. If you look right here, square root of 15 divided by square root of 3, you can combine those into there's just the square root of 5 and divided by 2 still. But now let's finally get the hypotenuse. Hypotenuse equals 2 times the short leg, and we just found out what the short leg was, so we're going to do 2 times that. So if you want to think this is being over 1, but these twos divide out or multiply out, and you get x equals square root of 5. Okay. For numbers 9 through 14, find the value of x, round your answers to the nearest tenth. For these, we're going to use SOHCAHTOA. SOHCAHTOA. Number 1, 67. This is opposite. This is hypotenuse. So that one's SOHCAHTOA. That one's going to be sine. So sine of 67 equals x over 14. Solve that for x. You're going to do 14 times sine of 67. Round to nearest tenth. You're going to get x is approximately 12.9. Sine of 67 equals x over 14. Solve for x, so you multiply 14 times sine 67. Number 10. Again, we're going based off of the 46-degree angle. This will be the hypotenuse, because it's across from the right angle. This will be opposite. So again, it's going to be sine again. SOHCAHTOA. So I'm going to say sine of 46 equals opposite 14 over hypotenuse x. Now remember, the shortcut when you want to solve for x and it's in the denominator like this is you're going to just switch. Just going to switch these two. So x equals 14 divided by sine 46. Type that in your calculator to make sure you know how to do that. But that's going to be x is approximately 19.5 when you round to the nearest tenth like it says. So 14 divided by sine 46. That's how you solve for x when it's in the denominator. Number 11, let's work off of the 23-degree angle. This will be the hypotenuse. And the x will be adjacent. So what trig function has adjacent and hypotenuse in it? According to our acronym, it's going to be CA, so cosine. Cosine 23 equals adjacent x over hypotenuse 20. Solve that for x by multiplying. So 20 times cosine 23 equals approximately 18.4. This is going to be the hypotenuse in number 12. This will be the adjacent side in number 12. So cosine 36 equals adjacent 14 over hypotenuse x. And again, if you want to solve for x and it's in the denominator, you're just going to switch these two around. Just switch them. X equals 14 divided by cosine 36. 17.3. Okay, two more. We just did two sines and two cosines, so I set up two more. They're both going to be tangents, okay? So 19 degrees is the angle we're looking at. 16 is opposite that angle. And the x is adjacent to that angle. Opposite and adjacent is tangent. So tangent of 19 degrees equals opposite over adjacent. So solve for x when it's in the denominator. It's going to switch these two around. 16 divided by tangent 19 is what you're going to type in your calculator. Approximately 46.5. Okay. Now the last one. This will be the opposite side to the 56-degree angle. This will be the adjacent side. So again, tangent of 56 degrees equals opposite x over adjacent 11. Solve for x, you're going to multiply 11 times tangent 56 equals 16.3 approximately. Okay. For numbers 15 through 20, find the measures of the indicated angle. Round your answers nearest tenth. So just to make it easier for us, let's label them all as x. Let's say x, 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 x. Okay, label all the angles as x. These are going to be the inverses. So again, the question is, are you going to do sine, cosine, or tangent? So for number 15, this is the hypotenuse. And this is opposite. So again, I'm just going to say the measure of angle x equals sine inverse 9 over 12. It's opposite over hypotenuse, so it's definitely sine. You want to solve for the angle, so you can use the inverse. So inverse sine 9 over 12. And it says round to nearest tenth, so I'm going to say the measure of angle x is approximately 48.6 degrees. Number 16, hypotenuse, opposite. So I'm going to say the measure of angle x, inverse sine, opposite over hypotenuse, so 28 over 31. Type that in your calculator. You might have to hit shift or second sign. 28 divided by 31, 64.6 degrees. Hypotenuse, adjacent side. So now, according to our acronym, SOHCAHTOA, we're going to do cosine. So again, for the review, I gave 2 sines. Now we're going to do 2 cosines, then we'll do 2 tangents on this section. So I'm going to say measure of angle x equals the inverse cosine of 41 over 55. $41.8 degrees. Number 18, hypotenuse, adjacent. Measure of angle x, inverse cosine, 25 over 54. 62.4 degrees. And now we're going to do two inverse tangent problems. So number 19, 4 will be the opposite side to angle x, and 16 will be the adjacent side. So the measure of angle x is going to equal tangent inverse, opposite over adjacent, so 4 over 16. Inverse tangent, 4 divided by 16 is going to give you 14.0 degrees. And number 20, last one in this section, looking at angle x, this will be the opposite side. This will be the adjacent side. So the measure of angle x, inverse tangent, opposite over adjacent, 41 over 45. 42.3 degrees. All right. 3 more problems on this quiz review. A square has a diagonal of 12 centimeters. What is the perimeter and area of the square? Express your answers in simplest radical form. Okay. Let's draw the square first of all. It's my square. Diagonal is 12. So one thing you have to know is that this is 90, because it's a square. And this is going to be 45, and that's going to be 45. Okay? And so we have 12 right there. So it's a 45, 45, 90 triangle. You want to find out the length of each side. So you want to find the leg. The leg equals hypotenuse divided by the square root of 2. Just jot that down. So 12 divided by square root of 2. Rationalize, multiply by square root of 2 over square root of 2. That'll give you 12 square root of 2 over 2. Which equals 6 square root of 2. Okay, so that is the length of each leg. Now we can find the perimeter and we can find the area. Okay. So what I'll do next is I'll label the diagram while we're at it. This is 6 square root of 2. 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 Let's do the perimeter next. Perimeter is when you add up all the sides. Or you can just multiply by 4 because it's a square. Think about it like if I said 6x plus 6x plus 6x plus 6x. That's 24x. So same thing here. 24 square root of 2 centimeters. And for the area, you're just going to do 6 square root of 2 times 6 square root of 2. So 6 times 6 is 36. The square root of 2 times the square root of 2 is 2. So area is going to equal 72 centimeters squared. I know we haven't done area yet in this class, but those units are squared. Okay, 2 more problems. Write all the possible trigonometric equations to solve for the length of yz, and then actually solve for the length of yz. Now this is a trick question. There's actually 4 possibilities to solve for yz, okay? Because you know this is 90, and you know that's 36. But you also know what this angle is. We'll get to that in a minute, okay? So one way to solve for yz is to do cosine of 36 equals opposite 10 over adjacent to yz. Another way to solve for yz, so maybe this will help if I put like a question mark right there, is to do tangent. We could say tangent 36 equals opposite I think I put the wrong one first of all. Hold on, give me 1 second to switch that. Put the wrong number. Okay, so restarting, okay, I put the wrong number right there and there, okay? It's been a very long day and I made a lot of videos so far today, so we're at the end of the last video I'm making, so there's going to be a few issues here and there, okay? But anyway, solve for yz. So one way to solve for yz is to use cosine. I can say cosine of 36 equals adjacent over hypotenuse. That's what I meant to write before, okay? Cosine of 36 equals adjacent over hypotenuse. Or you could use tangent of 36. Tangent of 36 equals opposite over adjacent. Okay? But there's actually 2 more ways to solve for yz, because you know that all the angles in a triangle add up to 180. So if that's 90 and that's 36, this one has to be 54 degrees. And now I can solve for it using sine. I can say sine of 54 equals opposite, which is yz, over hypotenuse, which is 17. Or I could say tangent of 54 equals opposite over adjacent. So what I would like you to do is now just solve for yz, and I want you to check that it's the same answer all 4 ways. I actually want you to check that, okay? So the first way, 17 times cosine 36 gives you approximately 13.8. It doesn't tell you where to round, so I'm just going to do approximately 13.8. That's how I got it when I did 17 times cosine 36. Now let's solve it using this way. Let's do 10 divided by tangent 36. You should get the same exact decimal, 13.8. Let's do 17 times sine 54. You get the same decimal, about 13.8. And the last one, 10 times tangent 54. You should get 13.8 approximately. Okay. And now one more problem. Find the value of w to the nearest degree. All right. So this is actually a tricky question. In order to find w, you need to know v first. Okay. So since that's a 90-degree angle, this one's also 90. So our game plan is solve for v, and then we can get w. So to solve for v, let's focus on the triangle on the left. And let's say sine of 65 degrees equals opposite, which is v, over hypotenuse, which is 15. Solve that for v. 15 times sine 65. I'm going to write out all the decimals now. I'm not going to round until the very end of the problem. 13.59461681. And now we can solve for W, because we know that the sine of W equals opposite over hypotenuse 21. So now we're focusing on the triangle on the right. Which is W equals inverse sine 13.59461681 divided by 21. So that's what you're going to type in your calculator. Again, don't round to the very end of the problem. That's why I kept all those decimals. But when you type that in your calculator, you're going to get W is approximately 40 degrees. Since W is on the inside, I don't have to put measure of angle W. I can just put W as approximately 40. Okay. W is approximately 40. So that was a good problem because it's a two-step problem. Okay. And that is the end of the review for the quiz on special right triangles, trigonometric ratios, and trigonometric inverses. I hope that was helpful.